Order real numbers. We are on page 353. Okay, so all real numbers correspond to a position on a number line. So we started off this unit and we plotted some points on a number line. Now we need to figure out where we can estimate the square root of 50 at, because the square root of 50 is an irrational number. It is not a rational number. And so we have to figure out where it is what perfect squares it's between. So hopefully you know your perfect squares. So find the two perfect squares that are closest to 50. One greater than 50 and one less than 50. And hopefully you know 7 squared is 49 and 8 squared is 64. So what are the two perfect squares? 49 and 64. What are the square roots of those two perfect squares? 7 and 8. So they're the whole number that most closely estimates the square root of 50, whole number, guys, would be 7, because it's closest to 49 is what is closest to 50. So we know that the square root of 50 is going to be 7 point something. So redefine your estimate of the square root of 50. Circle the true statement, then underline the value closer to 50. So let's look at this. So 7 squared, that's going to be 49. 7.1 squared. Well, I don't know that off the top of my head, so let's find it. 7.1 times 7.1. That'll get me 17749. So that's 114, 50.41. 50.41. Okay? Is 50 between those two numbers? Yes, it is. So this is the one. Oh, actually, circle the true statement. Okay, so I did that. Now you're going to underline the one that's closer. So what is closer to 50? Is 49 closer to 50, or is 50.41? So this one right here is closer to it. Okay, so we're going to do the same thing here. Sorry about that. Okay, so what perfect cubes is 100 between? So 3 cubed is equal to 27. 4 cubed is equal to 64. 5 cubed is equal to 125. So it is between 64 and 125. So it's going to be between 4 and 5. So, and on this, it would be good to use your calculator on this. So we're going to use our calculator on this, and 4.5 times 4.5 times 4.5. We get 91.125. Then, this amazing thing on your calculator that you can actually cube it. 97.336, 4.7, and I'm going to cube it, and I get 103.823. Okay, so it's between these two. It's between these two. So is 100 closer to 97.336? So So that's 100 minus 97.336. That would be a distance of 2.664. And this would be 3.823. So it's closer to this number right here. Within your interval, test cubes of the values expressed hundredths. Which cube is closer? Oh, I already did that. So it's approximately 4.6. Okay, so here we go. You can estimate the square roots to help you estimate and compare numerical expressions involving square roots. Compare the values between. So, if I look at this, 2 is what to 6? It is less than 6. So the square root of 3 plus 2, the square root of 3 plus 6. Okay, so we added the exact same thing on both sides of the equal sign, let's say. Since we added the same thing on both sides, 2 is still less than 6. So let's look at this next one over here. Negative 1 is what to negative 3? It's greater than. Again, I'm putting the same thing on both sides of the both sides of the inequality, I should say. So nothing is going to change. It is still going to be greater than. 6 and 7. 6 is less than 7. Oh, but we did something weird over here. We multiplied by 2 and the square root of 6 and 2 and the square root of 7. Okay? This part right here is still going to be smaller than this part right here, and we multiplied it by 2. So that means this is still less than. Negative 5 is going to be greater than negative 7. All we did was multiply by the exact same thing. So this is still going to be greater than that right there. Okay. Let's see. Complete the statement with consecutive integers. Consecutive means they go in order. So the next integer. So if I have 4, the next number is 5. The next number is 6, consecutive. Okay, so complete the statement with consecutive integers. 8 is between the perfect squares. Okay, so let's do this. 1 squared is 1, 2 squared is 4, 3 squared is 9. So 8 is between 4 and 9. So that means it's between 2 and 3. Use the information to complete the inequality with integer values. Okay, so if I had 2 and I had 3, and all they did was add 3 to both sides, so plus 3 and plus 3. That's all we're doing. So down here, the square root of 7 is going to be greater than the square root of 3. So if all I've done is multiply by 2 on both sides, that means that this is going to be greater than that. Square root of 11 is going to be smaller than the square root of 21. All we've done is multiply by 5. So this is still going to be smaller than. Okay, so 5 is between what perfect squares? So let's go back up here. 5 is between 4 and 9. So that means it's between 2 and 3. all they've done here is multiplied by 3. So I'm going to take 2 and I'm going to multiply by 3, and I'm going to take 3 and multiply it by 3. Okay, so we're going to look at these. I wish I had, so 1 squared, 1, 2 squared, 4, 3 squared, 9, 4 squared, 16, 5 squared, 25, 6 squared, 36, 7 squared, 49, 8 squared, 64, 9 squared, 81, 10 squared, 100, 11 squared, 121. Do I need to go any higher than that? No. Then I have cubes. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. Is that all I need for cubed roots? Yes. So let's look at this. So square root of 13. So 13 is between these two right here. So that means it's going to be between 3 and 4, but because they have this minus 1, I need to write minus 1. So this would be 2, and this would be 3 over here. So this would be between 2 and 3. The cubed root of 40. Okay. The cubed root, oh, that's not how you write cubed root. The cubed root of 40 is between 3 and 4. But here we've added 1 on both sides. So this is going to be 4 and 5. The cubed root of 25 is between 2 and 3. So if I'm adding 2 to it, it would be between 4 and 5. The square root of 121, or sorry, 1, so that would be between 10 and 11. So I'm taking away 4. So it would be 6 and 7. 109 is a, oops, sorry about that. 109 is between 10 and 11. So I'm subtracting 1, so 9 and 10. The square root of 30 is between 5 and 6, so we add 5, so I get 10 and 11. Identify the integers between which these numbers are located. Okay, so this is the same thing as 1/2. Or sorry, 1.5. So this is between 1 and 2. This is the same thing as 3.14. So it's between 3 and 4. The square root of 5. Well, the square root of 5 is between 2 and 3. And this is between 0 and 1. So 3 over 2 is 1.5. It's between 1 and 2. This right here is 3 over 2. So pi is between 3 and 4. Pi is right here. 2 and 3. It's closer to 2 than it is to 3. So I'm going to say about here. And 0.3 repeating. Okay. Identify consecutive integers between which number is located. So, 12. 12 is between 3 and 4. Remember, smaller number goes on the left, bigger number goes on the right. It's negative numbers. So, negative 475. So it's between negative 5 and negative 4. The square root of 3. The square root of 3 would be between these two. So 1 and 2. 1 and 2, but it's asking to subtract 8. So 1 minus 8 will get negative 7 and negative 6. 17 over 3. So 17 divided by 3, that would go in 5 times. So that's going to be 15, 2, 20, so that would be 6. That's 18, 2. So that's going to be the same thing as negative 5.6 repeating. So this is between negative 6 and negative 5. So we're going to plot these. So it's between negative 4 and negative 3. Negative 4, negative 3, it's closer to 16. That's 4 away. 9 is 3 away, so I'm going to say it's closer over here. So negative square root of 12. Negative 4.75, so that's going to be right here in the middle. Okay, between negative 7 and negative 6. That's going to be closer to 4, so it's closer to 2. So it's closer over here. So square, and then negative 5.6. So that's about here. And so negative 17 over 3. Okay, this would be less than. This is approximately 3 point something. This is approximately cubed root of 25. Oh, where did I do my cubed roots at? 25. Oh, right here. This will be closer to 3. So it's closer to 3. So ooh, that's a good one. If I do it on my calculator, um, 10, oh, no. 3.1 times 3.1 will get me 9.6, so 3.2 times 3.2 get me 10.24. Okay, and then 25, so 3.1 times 3.1 times 3.1, 29 point, oh, did I mess up on that? I may have messed up on that. Oh, it's going to be 2 point something. Oh, okay. Sorry about that. So it's automatically greater. Square root, so this is going to be 2 point something plus 4. The square root of 50 is going to be 7 point something plus 1. So this is going to be less than. Mark and Amber are producing a design for a side table. They want the top of the table to have the length of the square root of 7 feet and the side of the table Square root of 3. Estimate each length of to the nearest tenth. Then label the points on the number line. Okay, so the square root of 3. I'm going to do it up here. Okay, so that's going to be between the square root of 1 and the square root of 4. So it's going to be between 1 and 2. So I'm going to say, what's 1.5 times 1.5? I should just do that like this. Here. 1.5 squared equals 2.25. 1.6 squared is going to get 2.56. 1.7 squared is going to get... Why can't I do 289? 1.8 squared is going to get 3.24. So that's going to be 3.24, 2.89. That's 11 away, 2.89. So it's going to be about here. And that's the square root of 3. And then the square root of 7 is between the square root of 4 and the square root of 9. So 2 and 3. This is 3 away. This is 2 away. Okay, so 2.5 squared would get me 6.25. 2.6 squared, I don't know that one off the top. I should know that one. I think it's 676. Actually, yeah, 676. 2.7 squared, I definitely don't know. 7.29. Okay, so which one is it closest to? That one's 29 away. This one is 24 away. So 2.6 is right here. So the square root of 7. Okay. So this one is the square root of 14 between 3 and 3.5 or 3.5. Okay, so the square root of 14 is between the square root of 9 and the square root of 16. It is close. These two are closer to each other, so it's going to be on this one. So I'm going to say 3.5 squared gets me 12.25. 3.6 squared I get 12.96. Oh, that's super close. So I'm going to say it's approximately 3.9 or 3.6. The square root of 35. That's going to be between the square root of 25 and the square root of 36. Much closer to 36, so it's going to be on this end. So 5.85 times 5.85, that's going to get me 34.2225, and 5.9 squared gets me 34.81. And 5.95 squared gets me 35.40. So it's closer to 5.9. So the square root of 75 is between, is between the square root of 64 and the square root of 81. This is 11 away. This is 6 away, so it's closer to the 81. So I'm going to say that it's in this area. So 8.665 times 665 gives me 75.08. Ooh, I lied. It's actually going to be between these two. 8.655 times 8.655. And that's 8.655 is 74.909. So that's 0.09 away. So this is where it's closer to. So 8.665. Oops, that goes down there. How do the intervals selected in problem 7 help you to estimate the values of the square root? Get you closer to the actual number. To the nearest integer, to the nearest tenth. So this is going to be between 81 and 100. So it's closer to 9. And I'm going to go with 9.2. So 9.2 times 9.2 will get me 84.64. Oh, I guess I should have done 9.1. 9.1 times 9.1. That'll get me 82.81. Which one's it closer to? It is closer to 9.2. So in this one, what is it between? The cubed root of 27 and the cubed root of 64. So it's closer to the 4. So I'm going to say 3.8 cubed. So 3.8 times 3.8 times 3.8. This will get me 54.872. Okay, so it's close, but it's not quite there yet. So 3.9 cubed times 3.9 times 3.9. $59.319. So 3.9. Okay. The spiral of Theodorus was used to prove the irrationality of several square roots. Estimate the square root of 2 to the nearest hundredth. So the square root of 1 is square root of 2 is in between these. It is only 1 away here. It is 2 away here. So we have 1.5 squared would get me 2.25. 1.4 squared would get me 1.96. So that means it's between 1.4 and 1.5. Which one is it closer to? Well, it's going to be closer to the 1.4. So I'm going to do 1.41. Oops. And I'm going to square that. 1.41 times 1.41. and it'll get me 1.9881. 1.42 times 1.42 squared, that'll get me 2.0164. Okay? 2 minus 1.9881 will get, the difference here would be 0.0119. The difference here is 0.064. So it's closer here, so 1.41. Okay, so this part is exactly the same. So I'm only looking at this part right here, and this is greater than. Okay, the 2 is the same on both sides, so I'm only looking here. So this would be less than. Okay, the cubed root of 30, that's going to be between the cubed root of 27, which is 3, and the cubed root of 64. Okay, so it's going to be more than -3. So then that means that this is less than, oops, that was weird, less than. Down here, the square root of 8, where do I want to write this? Can I write it over here? So this is going to, 8 is going to be between 2 and 3. It's closer to 3, so 2.7-ish plus 1 gets me 3.8-ish. The square root of this is going to be 4.1-ish minus 2, get 2.1-ish, so this is going to be greater than. Complete the inequality using the greatest possible integer for comparison. Okay, so what integer is it between? So this is going to be between the square root of 36 and the square root of 49. So what's the integer? So 6. That is greater than 6. So this is going to be between the square root of 144 and the square root of 169. Okay, 150 is greater than 12. The square root of 225 and the square root of 289. So 15. And, oh, I don't know this one off the top of my head. This would be 420, so 19. I don't know off the top of my head. I should know it. It's 271. Oh, 361. So 19. Oh, I didn't even have to do it. Never mind. Circle the lesser of the two numbers. So this is going to be between the square root of 25 and the square root of 36. So it's going to be 5 point something. So 5 point something plus 4, that'll get 9. We're circling the, oh my gosh, the lesser. So square root of 11 will be between the square root of 9 and the square root. So it's going to be 3 point something. This will be between the square root of 16 and the square root of 25. So about 4.5-ish minus 2, that gets 2.5. So this is the smaller. This is going to be 2.7-ish cubed root. So this is going to be between the cubed root of 27 and the cubed root of 64. So it's 3 point something. So the lesser is this. So 15 minus 1 point something. And this is going to be 11 point something. So which one's smaller? This one. Okay, so the square root of 10. The square root of 10 is between the square root of 9 and the square root of 16. So this is going to be 3 on this side, 3 on this side, 4 on this side, add 4, so 7 and 8. This is going to be between 4 and 5, so we add 8, so 12 and 13. This is going to be between 7 and 8, so you subtract 5, and you get 2 and 3. 92. The square root of 92 is going to be between 9 and 10. You subtract 11, you get -2 and -1. The cubed root of 50 is going to be between 3 and 4. You minus 1, you get 2 and 3. The cubed root of 100 is going to be between 4 and 5, which would get us 6 and 7. The cubed root of 17 would get 2 cubed is 8, 2 and 3, so you would get 7 and 8. Is there a limit to the number of decimal places you can use to approximate an irrational number? Limit to the number of decimals. You must go far enough to see is repeating or terminates. Okay. So we're going to plot this on a number line. So the square root, this is going to be this between the square root of 9 and the square root of 16, so it's closer to the 3, so I'm going to put it about here, square root of 10. 7 over 4, that is the same thing as 1 and 3/4. So 1 and 3/4 would go here. 2.2 repeating would be about right here. This square root of 13 would be 3 point something minus 1. So 2 point something, that is closer. I'm going to say 13 is closer to, yeah, I'm going to say about here for the square root of 13 minus 1. This is between the negative square root of 16, negative square root of 9. So that's going to be negative 3.8-ish. So we're going to say negative square root of 15. This is going to be negative 1 and 2/3. Negative 1 and 2/3. It's about here, so negative 5/3. This is going to be negative 3. The square root, so that's between square root of 9 and the square root of 16. This is 3 away, this is 4 away, so it's closer to 3.4 minus 6, so that's negative 2 something, so about here for the square root of 16, or 12 minus 6. Okay, the square root of 24 would be between the square root of 16 and the square root of 25. It's closer to the 25, so I'm going to say 4.9-ish. Minus 5, so negative 0.1. So this is the square root of 24 minus 5. This is the square root of 36 and the square root of 49. So this is going to be 7 point. Oh, interesting. Ooh. Well, let's see. What's the square root of 24? 24 square root minus 5. Oh yeah, I was right. The 48 square root. Oh, that's the problem. That's 6.9 minus 8. That'll get down over here. Okay, I just square root of 48 minus 8. And this is going to be between the square root of 49, square root of 64. So that's going to be 7.78 maybe, minus 5. So that's going to be 2.8-ish. So that's the square root of 60 minus 5. And the square root of, that's between the square root of 16 and the square root of 25. So that's closer to 4.1-ish. There we go. Order the expression from least to greatest. Well, first of all, do we have any numbers that are negative? No, we don't. So the square root of 27 is going to be 5.2-ish. 17 over 6. 6 goes into 17. That's 2, or I should do it as a decimal. 2 and 5/6. The cubed root, that's going to be 4 point something, 3.14. So greatest to least. So the greatest number here is the square root of 27, then the cubed root of 70, then pi, then 17 over 6, then 1.8. This one, this is 0.6 repeating. This is going to be 1 point something. This is 0.2 repeating. This is 1.9, 1.8 minus 1, so that's negative 0.8. And then this is 1 and 1/9. Okay. So negative 1 goes first, so the square root of 3 minus 1. Negative, and then 2/9. And then 2/3. And then the square root of 2. No, I think this other one goes next. I think 10 over 9, and then the square root of 2. Okay, least to greatest. Okay. So 0.3 is 1.3-ish. So I multiply that by 2 and I get 2.6-ish. This is going to be 5.5 minus 8. So that get negative 2.6-ish. This is negative 2 plus 4.3. And so I would get 2.3-ish. This would be 4. It's going to be 16 over 4 minus 21 over 4. That'll get negative 5/4, so negative 1.25. Okay, so from least to greatest, so this is going to be the square root of 32 minus 8. And then 4 minus 21 over 4. And then 0.7 repeating. And then I'm going to say negative 2 plus the square root of 19. And then 2 radical 3. All this is without a calculator also, by the way. So if I got it wrong, I'm sorry. If I divide that, I get 2 and 2/5. This I get negative 6 plus 5 point something, so it's going to be negative negative 0.7-ish. We'll say this is going to be 3.9 minus 7, so that's going to get me negative 3.1-ish. 21 over 7 minus 30 over 7 will get us a negative 9 over 7. So that's negative 1 2/7. And this is 1.14, so negative 4/2. Okay, so the smallest number is negative 3 radical 2. Then the square root of 15 minus 7. And then 3 minus... Then negative 12 over 5. Then 3 minus 30 over 7. And then negative 6 plus the square root of 30. Which number is the best approximation? 3.14 times 3.14. That would get me 16. That's 4, 5. That's 12. That's 4, 1, 3. That is 12. 3, 4, 9, 6, 9, 4, 5, 7, 8, 9, 4 decimals, 9.8, 9.9. Which number is the best approximation for 3.14 divided by 3? Goes in 1 time. 0, bring down the 1, that would be 0. Bring down the 4, goes in 4 times, that's 12. That'll get me 2. 104. And I think it would be this one. Okay, there we go.